Okay, so today we're talking about similarity some more. In particular, let's talk about the different characteristics of similarity. For similar figures, right? This is the symbol for similar. They have certain characteristics, really two big things. The first is the corresponding angles are congruent. So in this case, let's say P would go with U. So angle P is congruent or equal to angle U, and we have about Q would go with V. So Q is equal to angle V, and then angle W would go with angle R. So we have all these angles are equal to one another, congruent, assuming that these two triangles are similar. Now, when they are similar, the corresponding sides are in proportion to one another. So what that means is if I were to set up, let's say, P, doesn't mean they're the same. They're not congruent to one another, but they have the same proportion. So like, for instance, PR right here would go with UW. So PR over UW, whatever that ends up being. Say if this was like 10 and 20, that proportion has to be equal to the proportion of, we'll say, PQ. About a different color here for PQ. PQ would be, I don't know, go with VU right here. So PQ, oops, that's an R, not a P. PQ over UV, that proportion has to be equal to one another. So like this was 10 over 20, this would have to be like 5 over 10. We're doubling them both of these, right? And the same would need to be true for the last set of these angles, these side lengths. So this side over here, QR over VW has to be equal. So all these need to be proportional to one another. So I'll just say, I don't know, 7 and 14, something like that, right? Where it have to be the same doubling scale factor for each one of these side lengths. So the proportion needs to be true for all of these, where if they reduce down, it has the same scale factor. Now, if these two triangles are similar, how we write this out, we'd say triangle PQR is similar, right? It's just that little squiggly line to triangle U. Let's see, let's make sure we do it in order here. So PQ would go with UV, UV, W. So it does matter kind of what the order you go with based on the angles. You gotta make sure those match up. All right, now let's look at something called angle-angle similarity of triangles. So if we have two corresponding angles, if they are congruent, then the triangles are similar. So I have just two angles. I don't have to have any other ones. All I need is just the two. So let's look at some examples here. Determine if I can say these are similar by angle-angle similarity. If yes, we'll write a similarity statement. So for instance, we have 74 and 75 in this triangle, and over here we have 75 and 31. Now what I'm going to do here, I got to figure out what that third angle is using the interior triangle theorem, saying that all three angles add up to 180. I would take away 75. That gives me 105. I'd take away the 74. That gives me 31, I believe. Got to think about it. Yep. So I got 31 degrees, which works out because I have 31, 31, and then I have the other 75, 75. So I could stop there. I know this last triangle is going to have 74 as well. All I need is just two angles. So since we'll say triangle ABC is similar to triangle, in this case, DEF, because of angle-angle theorem. Okay. All right, now look at this next one. We don't have really any numbers, but we do know that angle V is equal to angle Y. I need one more angle. In this case, this is a classic bow tie rule where I have these two angles are going to be congruent because of vertical angles. So I would say, in this case, because of angle-angle theorem, we can say that triangle, we'll say VWX is similar to triangle. Let's see, we'll go YZX. All right. So those two prove that it is true by angle. All right, we're going to look at a couple examples here to determine if these triangles are similar by the angle similarity. So for number one, we have parallel lines based right here. You can kind of see them a little bit. And then we have, looks like vertical angles. We can go ahead and mark these two are congruent to one another. Now, if I knew I had parallel lines here, we could also think about transversals and say alternate interior angles. So right here, these two would also be congruent. So therefore, since angle C is equal to angle G, and then also we'll say DEC is equal to angle FEG, then we can say therefore triangle CDE is similar to triangle GFE. We got two angles, right? That's all I needed. I got two angles that are congruent. These are similar, which means all my sides will be proportional and all my angles will be the same. All right, looking at number two, we got a case where we have these two triangles are kind of overlapping one another. So I can go ahead and assume that angle L is equal to angle L, right? That's a reflexive property, right? We have both of these, which should be the same because they are, in fact, on top of each other. Now I need to find one other angle. In this case, we have, again, parallel lines right here. So I'm going to think about, all right, I have a line going through my transversal. In this case, Q and M, those would not be equal to one another. Those would add up to 180. Same with P and N. So I don't have another second angle here. So in this case, I would say no, not similar. Right? I only had one angle. I needed two angles. So in this case, those two triangles are not similar to one another. All right, looking at number three, we have 39, 90 over here, and then we have 51 and 90. So I definitely got the 90, and the 90 is the same. I need to figure out on one of these triangles if the other one is going to be either 39 or 51. So let's figure out 180 minus 90 minus 31. That would give me, let's see, 59. So that works out well because now I have 59. Well, I wanted 51, didn't I? Wait, did I just have that wrong? I did. Oh, I wrote down 31 instead of 30. So this would be 39. And so then that would be 51. Whew, yikes. So I'd say 51 degrees. See, it's okay to make mistakes. It happens. It's okay. We got 51 and 51. So now we have two angles. We'd say similar to one another. So triangle, we'll say SEY is similar to triangle. Let's go right in order here. So S be WC. H. All right, because we have those two angles. All right, so we got the 68 and the 68. Let's find what the third angle is. Same thing here. I know two of my angles. I'll use, how about ABD here? I'll say 180 minus 68. That would give me 112 minus the 54. Let's see. Minus 54 would be 8. Sorry, doing a little math here. We got 58. That sounds right. Or is it 68? Did I do that wrong? I can't remember. 58 or 68. That will. It doesn't matter. Either way, it's not going to work, right? Even if it was. I think it is 58. We'll go with that. I'll check later. So 58 is not right there because 63 and 68. So we'd say not similar. We only have one angle that was the same. So you had to have two. So that one doesn't work. And then look at the last two. We have, looks like I need to do 180 minus 91. This would be 109. No. I'm blanking with my mental math right now. That'd be 79. 89. All right, so I got 89, and then minus the 67, that would be 22. So it gives me 22 right there. So I got 22, and then I have for the big triangle a 25, a 67, and then whatever's left over here. I'm guessing that's not going to work, but let's just try and make sure here. 180 minus 67 would be 113 minus 25 gives me 13 minus, so it'd be 93, 92. Yeah. So wait a minute. Struggling in my head here. Be 8. Got to work it out. 88. All right, so it gives me 88 degrees. Doesn't work. So we'd say not similar because we only have one angle that worked. This common angle down the bottom was shared. That was it. All right, looking at. Now I'm looking at that. See if I messed up the math anywhere. No, I don't think I did. All right, we'll double check later. We got 6. We have P and Z, so that those two are the same angles, and then we have, looks like, vertical angles in here. So we have 2 angles. We'd say triangle PXQ is similar to triangle, we'll say ZXY, because of these 2 angles are congruent to one another. And there you have it.